Swayam Prabha. Digital India. Educated India.
Welcome back to the course on optimization methods for civil engineering. So, in the last class we have discussed the search technique for single variable optimization problem, and we discussed about mainly region elimination technique, and before that we have applied the bracketed algorithm to bracket the optima, and after that we have applied mainly region elimination technique like golden section search technique, then interval halving technique, then bisection technique, and also we have discussed Newton-Raphson method. So, you can also apply Newton-Raphson method. So, that is to find out the optima of a single variable optimization problem. Now, in today's class we will discuss about multivariable functions. So, we will basically see how you can search the optimal point of a multivariable function. So, here I have shown you two variable functions. So, if I say this is function 1, this is relatively a easy function. So, there is only one optimal solution, and I can also say that this particular function is a convex function. Then if I say that this is function 2, that is the second function, and this is little bit complicated function because we have 4 optimal solution of this particular function within this search space. And third one, if I say this is third one, this is also relatively a difficult function because in this case also we have more than one optimal solution. The fourth one is a very complex function. There are several optimal solution, you can say the local optimal solutions of this particular problem, and one of them is the global optimal solution. Now, whatever line search method we will discuss, so we will basically assume that the problem is of this kind. Okay. So, that means the function is convex. Okay. And for the convex function, so we will apply the line search technique here. So, we will discuss a few line search technique, how we will solve this particular problem, and you can also apply the algorithm on other functions, but you may need some trial to get the optimal solution, but certainly I can say if you apply the problem on the fourth function. So, it will be quite difficult to solve this particular problem using this algorithm. So, let us assume that our function is of first kind, that is the convex function, and we have only one optimal solution of the problem, and let us discuss the algorithms. Now, this algorithm can be explained using the hill climbing problem. Suppose this is the optimal solution, or I can say this is the maxima of this particular function or particular hill, and I would like to find out this particular optimal point. Now, suppose you are here at this particular location. So, you are here, and what you will do basically, I can go along this direction, and I can do the line search. Suppose if I go along this direction, then my problem is a one dimensional problem. Basically what I will do, I will give one step, then another step like that, and once I will reach the optima, and I can declare that this is my optimal solution. Once you are going along a particular direction, so your problem is now not a multivariable problem, but it is a single variable problem along that direction. Now, if you are taking, suppose this is the point if you are taking, and I do not know which direction I should go, then suppose if you are going along this direction initially, then in this direction the problem is a single variable problem. So, I can give one step like that, and I can find out this is the optimal point in this particular direction. Similarly, suppose next direction is this, and in this direction also this is a single variable problem, and you are getting the optimal solution somewhere here, and maybe I can go along this direction and I can finally find out. So, therefore, the idea of solving a multivariable problem is to convert the problem to a single variable problem, and then you apply the line search technique you have already learned, that is golden section search method, then intervalapping method, Newton-Raphson method, and bisection method. So, any method you can apply. So, the problem here is that I do not have any specific algorithm for solving a multivariable problem, but what we are doing basically. So, we are converting the problem to a single variable problem, then we have the algorithm for solving single variable problem, then we are applying that one and we are getting the optimal point. So, idea here is that you have to get a direction. You have to get a direction, and suppose if I say I am here right now, I am here, and somehow if I am getting this particular direction and if I go along that direction, I will get the optimal solution. So, therefore, you have to get a direction and you go along that direction, find out the optimal point,